Okay, this problem at the bottom is a very difficult one to start with, but we're going to do it anyway. So show that this equation has a solution in the interval from 0 to 1. We're going to justify our answer. So this is, you might be saying, well, let's just solve it. Okay, no. Don't tell me what it is. Tell me that it has a solution. And this is a really funky way of going about doing it, but we're going to do it. So let's move everything over to one side. And we are going to define that as a function. We're going to say that. And now that we have defined that as a function, we've moved everything over to one side, we're going to say that it has a solution by saying that it's going to equal to 0. Okay, let's back up and just start all over. I want to show you not necessarily what the x value is, but I want to show you that there is an x value such that this is true. And how do I know that it equals 0? Well, I know that it equals 0 because I am looking for a solution, and a solution would be as if I moved everything over to one side and it would be equal to 0, so it has to work, okay? So now that we've treated it like a function, I need a couple things. I need to meet two conditions. Condition number 1, is the function continuous? Yes, it is. Let's change colors and start writing. I need to express that I have met those conditions. So f of x is continuous. How do you know? Well, because we've passed all the math classes up to this point and we know that, well, this is a constant, this is linear, and this is exponential, and there is nothing illegal about plugging in x into any of those. We never divide by 0. We have continuity. We're good. F of x is continuous on the entire real number line, but definitely from 0 to 1. Condition number 1. And let's meet condition number 2. Does this function equal 0 in between these two inputs? Well, I don't know that, so let's figure that out. Let's grab an ink pen or pencil. I'm going to find out what happens if I plug in a 0. I'm going to find out what happens if I plug in a 1. And if my desired output, and if you want to write that, you can. This is my desired output. Desired output. If my desired output is in between these two values, I can guarantee that there's an x value that will give you that. Don't know what it is, but I know it's there. Somewhere, at least one. So we're going to plug in a 0. We can do this one in our head. Plug in a 0 here. We have 2 minus, let's do this on paper actually, 2 minus e to the 0 minus 4 times 0. Well, 4 times 0 is 0. 2 minus e to the 0, that'd be 2 minus 1. That's going to give me 1. Okay? Now let's plug in a 1. 2 minus e to the 1 minus 4 times 1. And I don't know what that is off the top of my head, but I could grab a calculator. I would love to do that, but instead I'm going to just go ahead and write down what I know it to be because I have done this problem before. And I'm looking at where I'd previously done it. Okay, question. Is my desired output in between my two outputs? Is 0 in between is 0 in between 1 and negative 4.718? Yes, I have met my two conditions. All they said is show that it has a solution. In order to do that, I need to have two conditions met. Condition number 1 is met. Condition number 2 is met. F of 1 is this value. F of 1 is this value. F of 0 is this value, is 1. Oh my goodness, I'm so confusing in the way I'm explaining it. Let me try it again. 0 is between f of 1, which is negative, and f of 0, which is positive. 0 is between this negative value and this positive value. Therefore, 2 minus e to the x equals 4x has a solution on the interval from 0 to 1. What is it? Don't know, but I guaranteed that it existed.